Hello. So the problem that I chose to do was finding the equation of a plane using 3 points. So here the idea is that there is a plane in space somewhere, and we need to find the equation of this plane by using these 3 separate points. We can call them P, Q, and this is R. So what we want to do to solve this problem is to find the vector between P and R and P and Q. And these two vectors will be parallel to the surface of the plane. And then we find the normal vector of these two, which will be perpendicular to both of them and also to the plane, since these two vectors are parallel to the plane. So the vector that we find here will be also the normal vector to the entire plane. So in our problem we have 3 points. We can call them P, Q, and R. This can be P, this can be Q, this can be R. And we want to make these into 2 vectors like we had in the picture, like this. So we're going to have P be the vertex, and it'll be pointing to, there'll be a vector pointing from P to Q and then from P to R. So the way we find a vector is to subtract each component of the 2 points from each other. So we'll end up with 2 vectors. We'll end up with vector PQ and vector PR, and these are both vectors. And if we subtract Q from P, we'll get 1, -1, and 0. So that'll be 1 vector. That'll be this one. And if we subtract P from R, we'll get 1, 0, and -1. And that'll be the next vector. So now we have 2 different vectors, and we want to find a third vector that goes straight out perpendicular to both of these vectors, and also it'll be perpendicular to the plane. So the way we do this is we find the cross product of these 2 vectors, which we learned earlier in the class. So we have the I column, the J column, and the K column. And we'll put this vector into the first row, -1, 0, and we'll put this one into the second row, 1, 0, -1. And we can evaluate it now. So this will turn out to be I with -1, 0, 0, and -1 here, minus J, which will be 1, 0, 1, and -1, and that's plus the k component, which is 1, -1, 1, and 0. So multiplying these diagonally, we get 1 minus 0 I minus j -1 minus 0 plus k 0, and then we have minus -1, which is a positive 1. So this comes out to 1i, 1i plus 1j plus 1k, which is just simply I plus j plus k, and this is the vector 1, 1, 1, which is just the coefficients from I, j, and k. So this 1, 1, 1 vector is the vector perpendicular to both the PR and PQ vector, and also perpendicular to the plane. So now we have a vector that's normal to the plane, and we also have a point. We have 3 points, but we can use either one of them to solve this problem. So we have our normal vector 1, 1, 1, and we have a point 3. We can use the Q point. Could be anyone, but we can use Q. Oh, these are points. And what we're going to do is simply we're going to plug these two into the formula A times x minus x0 plus b times the y component minus the point plus c, same with the z's. So these letters A, B, and C are going to be the normal vector components, respectively A, B, and C, and x0, x0, y0, and z0, we can plug in these points for that. So with everything plugged in, it looks like this, and if we put everything together, it'll be x minus 1 plus y minus 0 plus z minus 1. And if we collect all the terms and put everything together, we get x plus y plus z is equal to 2. And this right here is the formula for the plane. And you can see that because if you get the normal vector from this plane formula, it's also 1, 1, 1. So that's it.